This is just our descriptive between subject factors. So this tells us that we labeled males as 1, we labeled females as 2, we have 6 males and 6 females. What this tells us is in political party, we labeled Republicans as 1 and Democrats as 2. We have 6 Republicans and 6 Democrats. That's consistent with our data here. We've got 3 in each cell. So the cells are actually broken down in the descriptives that we have here. And you might remember doing this in class. So what we have is a box for males here, and then it's split up by political party. So this mean of 7.67 represents the mean score of Donald Trump liking for male Republicans. They scored a 7.67. And all the way over here, we can see that there were 3 male Republicans, which is also consistent with this. We've got our 3 male Republicans there. So cool. We're looking good so far. Similarly here, we've got our male Democrats, which scored a liking of 1.67 out of 10 for Donald Trump. Between the 3 of them, that is their mean liking for Donald Trump. And there were 3 of them. If you want to see how all males meaned for liking Donald Trump, that'll be this total row. So of all the males, of all 6 males, there was a mean of 4.67. And this goes for both Republicans and Democrats in this made-up data set. Males, on average, liked Donald Trump 4.67. Which you'll probably notice is just the mean of the Republicans and the Democrats in this particular case. So same with the females. Female Republicans liked Donald Trump a mean of 5.67. Female Democrats liked Donald Trump a mean of 1.33. As a whole, females averaged 3.5 liking Donald Trump. This last one just shows us the means by party. So Republicans liked Donald Trump on average 6.67. Democrats liked him on average 1.5. So not too surprising, but again, this is all made up data. So here's the big table that you're going to want to look at to see if there are any main effects or if there are any interactions. So this is going to be a little bit weird because we have such a small sample size in this particular case, but just bear with me for a little bit. Ignore these first 2 rows, corrected model and intercept. We are not going to pay attention to. Let's go ahead and look at the row for gender. We don't need to look at the type 3 sum of squares. I honestly can't tell you exactly what that's used for. Someone probably more experienced and intelligent than I could explain that to you if you're curious. Here we have the between groups degrees of freedom for the gender analysis. So remember, we have 2 groups in gender. The first one is male, the second one is female. And remember that the between groups degrees of freedom is always the number of groups minus 1. So if we have 2 groups, we subtract 1, we get 1 degree of freedom. So this is consistent with what we know. So that's pretty neat. We go a little bit further over to the F column. We get our F value. This is F equals 4.9. And we get a significance value. This is our P value. So in this case, P equals 0.058, which is just greater than 0.05. So we would say P is greater than 0.05. There is no main effect of gender on liking Donald Trump. I'm sure if we got more participants, we would probably get a significant number, but in our analysis, that's just not the case. Let's see here. Let's move on to political party. This one's not very surprising at all. Political party, ignoring type 3 sum of squares again. Remember, again, we've got 2 groups. One is Democrat, one is Republican, 2 is Democrat. Between groups, degrees of freedom is just number of groups minus 1, so 2 minus 1 is 1. Again, not too surprising. We get that number that's consistent with what we know. Coming over here, we get this massive F value, which tells us between groups variance within groups variance is 96.1. We get a significance of 0.000, which is obscenely small. So we would say that there is a significant main effect of political party on liking Donald Trump. And at this point, we would kind of go back up to this table and say, okay, we can probably infer that Republicans like Democrats significantly more. So we would put that in our write-up. Republicans like Democrats significantly more, or excuse me, Republicans like Donald Trump significantly more than Democrats. Then we would write F parentheses 1, comma, I think we would use the 8, but I need to check on that. So 1, comma 8, and parentheses equals 96.1. P is less than 0.05 or P is less than 0.001, whichever one suits you better. So, final analysis. We're looking at this interaction between gender and political party. This interaction is a little bit hard to explain, but it's indicated by this little asterisk right between them. So it's basically taking gender times political party, trying to find an interaction between the two. Degrees of freedom is 1 here. I'm not going into the math of that. Our F value is only 2.5, and our P value is only 0.153. So we would say that there is no significant interaction between gender and political party on liking Donald Trump, and then we would report those values as necessary in APA style. APA style for a two-way ANOVA is exactly the same as either of the ANOVAs we've done so far. So just to show you what happens, and actually I'm curious too, I showed you that Bonferroni correction. Let's see what these significance values are if we do not correct for the number of analyses we're running at once. So we'll just go back into here. Whoops, I didn't mean to do that. All right, let's go back into here. General linear model, univariate. We will hit options, and then we will go back to LSD. I don't know what that means. I can't remember, but it's basically we're just doing that normal adjustment, which is no adjustment. We'll hit continue. We'll hit OK, and let's see what happens to our p-values. Oh, nothing. Okay, well. Never mind. Don't worry about it. Don't worry about it. Don't worry about it. Don't worry about Bonferroni correcting, I guess. I'll have to read up a little bit more about that. But essentially, you get the idea. This is how you run a two-way between groups ANOVA in SPSS. Complicated to run, complicated to interpret. If you have any questions, please ask me. I'm more than happy to discuss the concepts behind it. I think it's really interesting, and you'll have a lot of fun doing the homework. All right. Thanks for watching.